Hello guys, today we will be solving this question. It says A. Explain the difference between the terms EMF and potential difference. The potential difference across the terminals of a circuit is the work done per coulomb of charge in the external circuit, and the EMF of a battery is the work done per coulomb of charge in the complete circuit. Okay, now we do the B part. This is the diagram already drawn here. B says figure 10.28 shows a circuit containing the batteries and resistors. You may assume that the batteries have negligible internal resistance. This is the diagram here. Roman 1 then says use Kirchhoff'S first law to find the current in the 4 ohm and 8 ohm resistor. This is the 4 ohm resistor and this is the 8 ohm resistor. Remember, current always moves in the direction of this longer line. Since it's on the left, it means current will also move towards the left. When it gets to this junction, it splits into I2. So this is I1, this will be I3, when it gets here to this another junction here, it will split into, let's say, I4. And here we say I5. It splits here, then comes and joins back here, then continues. So they say using Kirchhoff's law. Here we will deal with Kirchhoff's first law. Kirchhoff's first law, it says that the sum of currents entering a junction in a circuit is equal to the sum of currents leaving that same junction. The simplified form says total current entering is equal to total current leaving. So we apply that now by saying this is a junction. Total current entering is I1 equals to total current leaving. Total current leaving the junction is what? I2 and I3 equals to I2 plus I3. Here I3 has been given and I1 has also been given, and I2 then will be equals to what? Will be equal to, this crosses this way and becomes negative, becomes I1 minus I3, which gives what? I1 1.75 minus I3, which is 1.0. So I2 will be equals to 0.75 amperes. Now Roman 2, calculate the EMF of E1. Remember, EMF refers to the voltage of the battery, while PD, potential difference, refers to the voltage of the resistors. This is loop 1. This is loop 2. And this is loop 3. Okay, and you're looking for what? E1, the EMF of E1. So you use this loop to get it. How do you do it? You use Ohm's law, which says V is equals to IR to determine the voltage of what? These resistors. And now you're using, remember, if current moves in same direction as the loop, you have a positive value, and if current moves in opposite direction as your loop, you have a negative value. I hope it's clear. Now you proceed. Remember Kirchhoff's second law, the simplified version says the total voltage of batteries is equal to the total voltage of resistors. So what is the voltage of the batteries in this loop? There's only one battery there. So what is voltage? Its voltage is, you write negative E1 because the current is moving towards the left while the loop is going towards the right. Since they are opposite directions, it must be negative. That's why you put a negative voltage for this loop here. Next is this one, from the law, equals to the total voltage of resistors. You are done with voltage of batteries because there's only one battery there. Now you are doing the voltage of the resistors. Resistor, remember voltage is equals to IR. Current to it is I2. I2, its resistance is 4 ohms, and it must be negative because current is moving like this and the loop is going like this, so it must be negative. And for resistance, the same thing. Here its current is moving like this and its loop is going like this, so it's also negative. Negative what? I2 multiplied by 8 to get the voltage. So the voltage of the batteries is equal to the voltage of the resistors. From here, I2 is already gotten. I2 is already gotten, so we just solve for E1. So E1 will be equals to 9.0 volts. Okay, Roman 3 says calculate the value of E2. This is E2 here. You are looking for the value of E2. So here you will use this loop here, loop 2, to get this value of E2. Its current is moving towards the right, but the loop is going towards the left, so it's negative. You write negative E2 for I2, same direction as the loop, positive 8 I2. This here, opposite direction from the loop. Here, so you must have a negative. Remember, current here is moving towards the right. Equals to 4 into I2 0.75 plus 8 into 0.75 minus 3 into I3. I3 is 1.0. So negative E2 will be equal to, this negative means the current flows in the opposite direction. Question 4 says calculate the current in the 12.0 ohms resistor. First, you have to draw it. Negative 12 I 3b. So I negative I 3b will be equal to 6 divided by 12, which gives 0.5 ampere, and I 3b will then be equal to negative 0.5 ampere. Remember, current always moves in the direction of the longer line. That's why it's negative, showing that we took the opposite direction.